Hi Level 3s and welcome back to 3.6 Aqueous Chemistry. This is Lesson 4 Part B. So just carrying on, here's a question. This time it says write an equation, a Ks expression, and explain the Ks value for lead hydroxide. So lead hydroxide is what we're dissolving, so we write lead hydroxide here. Okay, we don't include water in any of these equations because aqueous means dissolved in water. A pinch point to watch for is because there's a 2 behind the bracket here, we need a 2 here. So this is the equation, you must do states. So we've done the first one, we've written the equation. We can now write the Ks expression, products divided by reactants. Remembering we don't put the 2 in front of the OH minus, instead we put it to the power of, and we don't divide by the reactant because it's a solid, so we just leave that off. Okay. The next thing is to discuss the size of this Ks. Okay, so it's a relatively small Ks, and this means that not much of the PbOH2 will dissolve. Okay, and we know that because a Ks is the ratio of products to reactants, and we can see that we have, because it's small, we've got much more reactants, which means we have far more of the solid than we do the ions, and therefore very little of it dissolves. Okay, and this is what I've put here. So let's do the same again, but this time for calcium carbonate. So calcium carbonate solid, equilibrium arrows goes to calcium ions aqueous, plus carbonate ions aqueous. Okay, states are very important. Okay, this is a 1-to-1 this time, so we don't have to worry about anything else. Ks equals Ca2 plus CO3 2 minus. Okay, what can we say about the value? The Ks value is small. Okay, this means there's a higher concentration of reactants compared to products, so this means very little of the CaCO3 will dissolve, and this means it's pretty much insoluble, or not very soluble, either way you want to say it. Okay, and that's what I've put here. So let's summarize what we've learnt today. What does a Ks tell us? It tells us the concentration of products compared to reactants. So a large Ks tells us there's a greater concentration of reactants. The products is a much greater concentration than the reactants. A small Ks tells us the concentration of the reactants is much greater than the products. So this one here, products is greater than reactants, and this one here, reactants is much greater than products. Okay, remember you can always plug into that, the Kc 4 divided by 2 equals 2, or 2 divided by 4 equals 0.5 to remind yourself. So we say when you've got a large Ks that the reaction pretty much goes to completion because you get lots of products. Okay, and that means that mostly you have ions present because when a solid dissolves, it dissolves into ions. Okay, so we mostly have ions. If you have a small Ks, the reaction doesn't really occur that much. Most of the reactants stay intact, okay, and so you mostly have solid. So that's the big comparison. So a small Ks, just to give you a bit of a range this year, a small Ks is kind of 10 to the negative 4 range, okay, and a big Ks is anything bigger than that. So 10 to the negative 11 would be big. You'll start to be familiar with what big and small as we start going through problems. Okay. Here's a video if you want to watch some more on solubility. Otherwise, this is the task that you have to do. You have to do the Ks worksheet, which is on your OneNote. You just need to, for this task, you are only writing the equations and the Ks expressions. We'll be doing calculating solubility next lesson. And the other thing that you're going to do is page 242 of the SciPad. Okay, team, I'll see you next lesson for lesson 5.